afternoon, ladies and gentlemen. My name is Dr. John Belkowitz. I'm the Director of R&D here at Intelligent Concrete, where we specialize in the magical world of concrete. I'm working tonight with you parents out there who are homeschooling your kids during this crazy time for e-learning. And hey, listen, I let us know what questions you have. Send us a direct message. We'll definitely go over any type of math problem, chemistry, physics. We're focusing a lot on engineering. We're going to be doing some more volume-based related math problems today. I've got, I think, 3 of them for you. So we'll focus on that. But if there's any other questions that you want us to get to, like chemistry or physics related, we can do that too. Just let us know. So let's get into it. So we're doing volume-based mathematics. And what that means is, if you can imagine a cylinder with a diameter of 4 inches and a height of 8 inches, the 2 questions is, what is the surface area in square inches, and what is the volume in cubic inches, and then what is the volume in cubic feet? We'll go ahead and do 2 types of problems here. So the first one here is our surface area, and what we said is our diameter here is 4. Maybe I could draw that a little bit better. That's pretty ugly. So my height I said was 8 inches, and I said my diameter was 4 inches. Okay, so our equation for area, for our surface area, is equal to pi r squared, or we can say it's also equal to d over 2, our diameter over 2, because our radius equals half of our diameter squared, so we could say that's pi times diameter over, so that's diameter squared, over 4. Oh my gosh. I couldn't do the math there for a second. Hey, and listen, even the brightest PhDs need to joggle their brain every once in a while to remember simple math equations. So if you get stumped, even in front of your kids on these math equations, play it off. We're not all of us are idiot savants who could do this stuff like art in our heads. Most of us, the 99% of us, have to write this out. So if you screw something up, erase it. That's why God put erasers on pencils, because we're humans and not robots. So if you make a mistake, don't worry about it. Write it up. Or write it up. You know what I mean. Clean it up. Okay, so if we go ahead and do the math, our pi, which is 3.14, nice little button on the calc, times our diameter, which is 4 inches, and of course, don't forget we got to square that, all over 4 equals, I already know the number, but I want to do the math with y'all, because I know you're doing the math. So 4 inches squared divided by 4 times pi equals 12.57. So our surface area here is 12.57 inches squared. And this is something that you want to focus on, not only the number, but the units. Because if you don't get inches squared at the end of this, then something went wrong. Because that's what our surface area units are in, is inches squared. So if you got inch over inch, or if you got cubic inches, or 1, or inch to the -1, or whatever, not right. For surface area, you always want inches squared. Or you always want a squared value. It could be meters squared, inches squared, feet squared, hectares squared, whatever. But you always want something squared. Okay, so let me write that over here, 12.57 inches squared. I'm going to go ahead and erase all of this. And you know what? I erased my diameters, 4 inches, and our height equals 8 inches. Right, okay, so we're good, we're good. So I'm going to leave, where did my red marker go? There. So I'm going to leave my equations here. So for my surface area in inches squared equals, what did that equal? Pi times diameter over 4 squared. Now, for my volume is really awesome. My volume in cubic inches is going to equal my surface area times my height. Okay? Now, if I wanted to spell that or derive that, it's going to be pi times diameter over 4 squared times my height. Okay? So if I want to throw my numbers in there, I already have my surface area, which was 12.57 inches squared times 8 inches. Right? So now we started off, we got this, our surface area. Now that's what this 12.57 is. Now we want to multiply that surface area by our total height, our 8 inches, to get our volume. And in doing so, times 8 gives us 100.53 inches cubed. Now, this is awesome. The reason why I chose this specific shape is because this is the size of everyday or the concrete cylinders that are used to determine the strength of concrete that goes out in the field to build our civil infrastructure throughout the entire world. So we have to, when we design mixes, when we do things in the lab, when we bring out samples, we have to determine how much concrete. And oftentimes we, after we figure it out like 5 or 6 times, you know how much, unless you're working in the lab and you've got to design a very specific batch for the samples that you need, then you'll need to do this math. But this is directly related to an occupation. Now here's the thing. In our industry, in the construction and concrete industry, we don't use cubic inches, we use cubic feet. So let's just write this cubic inches down so we have that. But the second part of this problem that I'm going to do, inches cubed, remember I'm always looking at those units. With volume, it's a cubic something, cubic feet, cubic inches, cubic meters. So we got that. Now I want to do is I want to convert that volume, volume equals surface area times height. What does that equal? Pi times d over 4 times, or squared times height. Okay, that's great. Now I want to convert. I want to convert my volume in cubic inches to volume in cubic feet. So I want volume in cubic feet, and what that's going to be equal to is our volume in cubic inches times, or in our case, divided by some conversion factor. Right? So our volume here in cubic feet is going to equal, what was our volume? 100.53 cubic, or excuse me, I could just do this, inches cubed, cubic inches divided by 1,728 inches cubed for cubic foot. Now, where did I get this from? I pulled this from a book. You could pull it from Wikipedia. You look for conversion factors, convert cubic inches to cubic feet, and you get this, there are 17,000 or 1,728 cubic inches per cubic foot. So when I do that, when I divide that by 1,728, now it just happens to be that I use that nonstop. I mean, that's just something that is part of our arsenal that we use in the lab every day. So we've got a volume of 0.06 cubic feet in one of these cylinders. Now, if I'm doing a standardized set of submittals for, let's say, the Colorado Department of Transportation, I need 1, 3, 7, and 28-day breaks. And actually, it's 3, 7, and 28-day breaks. Now, the thing is, for each one of those breaks, I don't need one of these cylinders. I need 3 of those cylinders. So if I have 3, 7, and 28-day breaks at 3 cylinders each, that means I need 9 cylinders. 9 times 0.06 gives me 0.54. So if I have 0.54 cubic feet, and the standard tells me that I need at least 1 cubic foot of concrete made for a submittal mix, and I need 0.54, I have more than enough cylinders to run this test, because I have to bear in mind that I have to take out 1/4 of a cubic foot from the mix to do my unit weight test and my air test, and then there's going to be some concrete left over in the mixer, in the lab mixer, mind you, that I'm not going to be able to pull out. So having somewhere around 0.75, 0.75, 0.65 to do 0.54 cubic feet worth of concrete is not a bad amount of waste to have when you're doing something like this. So math that the kids will learn in school, and there's a real world scenario of where they'll actually use that math. So awesome sauce. I think we're good with that. Yeah, thanks for joining us today. Don't forget to like and subscribe. Ding that bell for notifications. Go concrete! It is on!